Hello, good morning to all of you. So in today's class, we'll be discussing few of the initial C++ programs. So let us discuss the first program, that is my first C++ program. So here you see the first statement that I have is hash include iostream.h. So here what I've done is I've included a header file that is called as iostream.h. Now, as in case of C programming, where you must have included stdio.h file or console input output.h file or map.h file. So likewise here iostream.h is a header file that contains description of something. So let us as of now just try to understand that we are including header file iostream.h. So iostream basically stands for input output stream. So any object that is capable of managing input output stream is defined inside this particular header file. So this is the importance of iostream.h file. So for an example, any function that is capable of working with standard input output is defined in stdio.h. Likewise here, any object that is capable of manipulating or that is capable of working with input output stream is defined in iostream.h. Now what is iostream? Iostream is basically a combination of iStream and OStream, that is input stream and output stream. Now stream in case of programming is nothing but a sequence of bytes. So any sequence of byte is called as a stream. So whenever a program has to read data from it, has to read data from a stream, and whenever it produces any data and has to place some data, it will place it in a stream. So a stream is nothing but a collection of bytes, that is a continuous collection of bytes. So, for an example, a book, a very simple book, can be considered as a stream because it contains a sequence of characters where each character will take one byte. Okay, so here a book is a stream of bytes, so it's a stream. So that basically implies that the streams are nothing but files in programming paradigm. Okay, streams are nothing but files in programming paradigm. So you have files associated with the input stream and the output stream. So it can be either input stream or it can be either output stream, or it can be any named stream as well. So you can place you can read data from your own specified file, or you can write data into your own specified file. So that can also be done. So for now, just remember, a stream is a collection of bytes. Stream is a continuous collection of bytes from where the bytes may be taken up or bytes may be placed to. Now here what I have is I have defined my main function. So void main. So here the return type of main is void. That basically means main is capable of returning nothing. So here main, just remember, just for your understanding, main is either capable of returning void or it's capable of returning integer. So if main returns integer, then the return value of main has certain significance. So if it returns 0, it means the program has normally terminated. If it returns non-zero, that means program has abnormally terminated, right? Now there might be a question, to which function main returns the value to. Now just listen to me carefully. So whenever you execute a C++ or C program or Java program, what you tend to do is you tend to send a request to the operating system kernel. The operating system kernel on your behalf will be executing the program or invoking the main function for you, right? Okay, so it's not you who is invoking the main function, it is your request to the operating system kernel which leads to kernel calling the main function, and then execution of main function is done. So whatever main returns, main will return to the operating system kernel, and the operating system kernel will further convey it to us. So whatever value main returns, it returns to the operating system kernel. So here main is returning nothing. Again, I'll repeat, main can return integer value as well. So a 0 value represents normal termination, and a non-zero value represents an abnormal termination. Okay. Now, why we call this particular function as main is because in case if a program, the program compilation and program execution starts from a main function. Okay, right? So again, I'll repeat it. Program execution, program compilation, and program execution starts from main function. That implies that MAIN, this identifier, MAIN, it's an identifier. It marks the beginning of program definition in memory. So in case of high level and middle level programming, what we are not allowed to do is we are not allowed to work with the absolute address. So I cannot say that I'll go to address number 4040 and start executing the program. Instead, here what I'll do is I'll go to the address that is equivalent to that of MAIN. So whenever you print the integer equivalent of MAIN, it will give you the address of MAIN. So here main marks the beginning of program definition in memory. So whenever you execute a program, so the control will be transferred to this particular address, and whatever instruction that lies in this particular sequence of address will be executed. Now here just see, so whenever the compilation or the execution has to be done, it will always start from main. So that implies that you can have only one main function in your C program. If there are more than one main function, then definitely there will be an ambiguity which one to execute, right? So compiler may not be able to select which main function to start compilation from, and later on the execution as well. So now, so what we need to have is we need to have only one main function. So till now what we have learned is we have learned about what is iostream.h and what is significance of writing void main. Now inside main, what I have is I have written C out. Now it is spelled as C out. Okay, it's spelled as C out. Now C out. So in case of C programming, if you remember, you must have written printf for printing the statement into standard output stream. But here, what we're doing is, since it's an object-oriented paradigm, what we're doing is we're using the object cout. So object cout is an object of iostream. Okay, right? Object cout is an object of iostream. So what does it basically do is it basically takes in this particular string to itself. So cout will be initialized with hello world, okay, and then the content of cout will be sent to the output stream. So that is the way how it basically works. So it's basically a transient carrier, right? Okay, so cout is an object of iostream which tries to take in this particular string, that is hello world, and then it tries to place it in the standard output stream. Now here what I have is I have a bitwise operator, that is left shift bitwise operator. Now here this particular operator is overloaded in order to perform the task of insertion. Okay, right? So here again I'll repeat it. Here bitwise operator, that is left shift, is overloaded in order to perform the task of insertion, right? Okay, so this is the way how it basically works. So here again I'll repeat it. So what we have done is we have included iostream.h, right, and then we have defined the main function where we have a very simple statement, that is hello world, that is to be printed. Now whenever this particular program executes, first what happens is that preprocessor will be initiated. Now as you all know, whenever you execute a program, there are three set of programs that are associated with the execution of C program. One is called as preprocessor, one is called as compiler, and the third one is called as linger. So the preprocessor processes all the statement that starts with hash. So that is the responsibility of preprocessor. So that is the reason why what we do is we place hash for every statement that the preprocessor has to execute. So first, preprocessor will search for a statement that starts with hash. It will look for the activity that is to be performed. So here the activity that is to be performed is include. Include what? stdio.h file where in your C program, because stdio.h may be located somewhere else. So what I need to do is, in order to make this particular header file usable, I need to make a copy of that header file and place it in my C program. So that's why you see whenever you compile your C program, you will see that you will have almost 250 lines of code getting compiled, because this iostream.h also gets compiled. So that is the task of the preprocessor. So preprocessor processes all the statement that starts with hash, and it will look for the activity that is to be performed. So here the activity that is to be performed is include. So include what? Include iostream.h where in your C++ program. So then eventually, once the header files have been included, or all the statements starting with hash has been processed, then comes the role of the compiler. So here now the compiler starts from main function. What it will try to do is it will try to translate the entire program into equivalent object code, right? So the role of the compiler is to translate the program into equivalent object code. So when the translation process is carried out, if there is any grammatical mistake that the compiler cannot convert, so it will say that I cannot convert it. So this is the point in time where I cannot convert it. So compiler is not a program that detects error. Compiler is rather a program that tries to convert a program into a binary equivalent. The place where it cannot convert, it will say that this cannot be converted because this is not a valid grammatical statement. So once the compiler translates the entire program into bytecode, then what we need to do is we need to call the linker. So the linker will call the link, will link the function definition to the a function call to the function definition. So just see, these are the rules that are. So eventually what you'll have is you'll have an executable file created out of this particular program. So first, all the start statement that starts with hash is processed by the preprocessor and the associated activities are performed, and then the compiler translates the entire program into bytecode, and then eventually the linker links the function call to the function definition, thus creating an executable file for this particular program. So whenever you execute a C++ or a C program or Java or any other program written using any other platform, it's not the .c file or .cpp file that you're executing. It's .exe of that particular file that is getting executed, that is created after the linker links the function call to the function definition. So it's very important for you to know the role of the preprocessor, the role of the compiler, and the role of the linker. So here, this is a very simple program that prints hello world. Now let us move to the second program. So here, just see, in the second program what I have done is I have written a very simple program that is capable of adding two numbers and capable of finding average of two numbers. So here what I have done is I have declared two numbers, number 1 and number 2, and sum and average as variable of type float. So whenever variable is declared, what will happen? Memory allocation for the variable will be done. Now after that, in contrast to cout, what I have is I have an object of istream.h that is called a cin. Okay, cin object is capable of reading value for a given variable. So here, just see, here what I need not do is I need not, as in case of C, you must have noticed I have not specified the format specification. I have not specified %f or %d or %c for data of different formats. So here that is not mandatory. So here, just see, what I have is I have cin object, okay, cin object that is capable of so first what we'll do, we'll read data from the input stream. Okay, we'll read data from the input stream, place it in cin, and eventually that particular value is placed in num1. Okay, right, like in case of cout, the cout will be initialized with the string, then the content of the string will be placed in standard output stream. So here what I'll do is I'll first place the value in cin and then place the value in num1. Okay, right, now just see the way how the operators are being overloaded. So here what we have is we have the left shift operator. Here what we have is we have the right shift operator. So here what I'm doing now is I'm reading two values, num1 and num2, and then what I'm doing is I'm finding sum of num1 and num2. I'm finding sum of num1 and num2 and I'm initializing it to sum. So sum is also a floating point variable. So num1 and num2 will be added and will be initialized to sum. Likewise, I'm finding the average, where what I'm doing is I'm dividing sum by 2. So sum by 2 will be initialized to average. Then I'm printing the value of sum and I'm printing the value of average. So here what I can also do is I can also cascade multiple shift operators. You see, so here what I have is I have cascading of multiple shift operators that are there. So this particular program is capable of just finding the sum and the average of two numbers. Okay, so this is a sample C++ program that exhibits the property of cin and cout. Now likewise, here what we have is we have a third program that tries to further elaborate on the example of the program in C++. So here we have the third program that is capable of and expressing the class characteristics of C++. So here what I have is I have included the header file iostream.h, right? Now what I have is I have a class person. Now I have the private members in this particular class, that is name and age, right? So here, since the access specifiers are not provided by default, as I've already said, if you go through the theory classes, you'll find out that by default the access specifier of the members of the class will be private. So here name and age is private member, and what I have is I have two functions, get data and display. Get data and display. These are placed in the public section of the class person, right? Okay, so the class declaration terminates here. So here in this particular program, what I have is I have four members, two are data member and two are member function. The data members are public in private in nature, and the member functions are public in nature. So here now, just see what I have done is I have defined the function outside the class. So in order to define the function outside the class, so what I have to do is I have to place the scope resolution operator. So here the scope resolution operator basically tries to devise a mechanism for accessing the function outside the class. So here just see the return type of get data is void. So return type of get data is void here. Person is the class name. You have the scope resolution operator, and then you have the function name and the argument list. So the argument list is void here. So this particular function is capable of reading data into the members of the class. Now since name and age are private members of the class, since name and age are private members of the class, so what I cannot do is I cannot have an object in the main function that is capable of initializing the values of name and age. So here what I have done is through the member function, what I have done is I have made an access to name and age, right? Okay, so this is the way how private members can be accessed. Now likewise, what I have is I have a function that is capable of displaying. So since I'm defining the function outside the class, again what I need to do is I need to use the scope resolution operator. So person is the class here and displays the function, so it will display the name and age. Now in the main function, what I have done, just see I have declared an object of type person, that is p. So I've written p.getData, p.display, right? Okay, so it will get the data and it will display the data. Now here the important thing that you need to understand is that the way how the private members can be accessed, you see private members can be accessed only using the member function. So here I'm using only the member function to access the private members, right? Okay, and eventually in the main function I've declared an object, and the object is trying to access the private member through the member functions. This is the thing that is very much important for you to understand. So this we have discussed in the theory lectures as well. Right, now just see the next program. Okay, the next program is the example of a reference to a variable. Now reference variable, as I've said, as we have discussed in theory class, is nothing but a reference to a variable. Okay, reference variables are nothing but reference to a variable or allies or an alternative name used for a particular variable. So here what I've done is I've declared two variables, I and d. I is of type integer and d is of type double. Now here what I have done is I have declared two reference variables, r and s. Okay, so r is a reference variable that is capable of creating a reference to integer variable, and s is a reference that is capable of creating a reference to double. Okay, right? So here this should be small d, right? There's a typo error here. Now just see we have learned in the so if you go through the theory classes for reference variable, you'll see that reference variable has to be initialized whenever it's declared. That is one of the major difference between a pointer and a reference variable. So the reference variable has to be initialized whenever it's declared, and what you cannot do is you cannot alter the content of the reference variable. So once it is initialized to I cannot use this reference variable r to point to some other integer. So these are the properties of the reference variable. So if you go through the theory lectures, you'll find out the properties of the reference variable. But these are the two common properties, that whenever the reference variables are declared, the reference variable has to be initialized, and it cannot have multiple instances, right? Again, or it cannot hold multiple references. So now just see here, we have a reference variable r, which is initialized with I, and we have reference variable s that is initialized with t. So to I have initialized 5, so the value of I is 5. So what I can do now is I can use R alternatively to refer to the value of I, that is 5. You see, so see out the value of I. So what I've done is I have used direct memory access. Okay, so in this case it will give me 5, but here I've used reference to I, that is R, so here it will also give me 5. So both the statements will display 5 because R is a reference to I, right? So whenever I'm trying to access I directly, so here you see what I'll have is I'll have 5, and if I try to access I indirectly through R, so what I have is I have 5, right? So here just see now again D is initialized with a float with a value of type double, that is 11.7. Now S is a reference to D, so what I can do is I can use D or S for printing the value of D. So here I'm printing the value of D, so it will print 11.7. Here also it will print 11.7 because S is a reference to D. Now this is the next program that you have to execute, right? So this shows the way how the reference variables can be used in a C++ program. Now what we have is we have a program that is capable of it's capable of reflecting a mechanism for accessing global variable when there is a local variable by the same name, and it basically tries to show the way how scope resolution operator can be used. Now just see here what I have is I have hashing, so I have included the iostream.h header file. I have declared a global variable x. Okay, this is a global variable x. Now inside main what I have is I have a local x. You see I have a local x, so that is initialized to 10. So now in order to get the value of global x, what I can do is I can use the scope resolution operator. So here I'm using the scope resolution operator in order to get the global value. So this is one of the way how scope resolution operator can be used in order to access the global variable if there exists a local variable by the same name. So since global variables are initialized with 0, so this particular statement will give me 0 because the value of the global x is 0, right? Because by default it's initialized with 0. But in this case, you see here I'm printing the local value of x, so this will give me 10. So this is one of the way how what you can do is you can use the scope resolution operator. Now just see and the sixth program that we have, so defining a function outside the class. So as I've already said, one of the very purpose of scope resolution operator is to help us in defining the function outside a class. So here you see I have a class A where I have a member function void fun. So now this is just a plain simple declaration, but what I have done is I've defined the function somewhere else. You see the function is defined outside the class. So here what I'm doing is I'm using the scope resolution operator in order to access the function belonging to a particular class. So here void is the return type of the function, A is the class, scope resolution operator, and the function name. So it basically means fun is a function that belongs to class A, because there might be multiple instances of fun belonging to other classes as well. So this signifies that fun is a function that belongs to class A. So just see here what I've done is I've declared a simple object of type A, and I've called function that will print this particular statement in the standard output stream. So just see, these are the first 6 programs that you have to execute. So what we have done is we have started with a very simple C program, right, where we have learned the significance of including iostream.h, right. Then we have learned about a program that's capable of adding 2 numbers and finding an average of that, and then we have understood class with the help of an example where we have members inside the class being declared. Some are declared as private, some are declared as public. So we have learned about how to access the private members through the member function. Okay, right. Then we moved on to the example of reference variable, how we can use allies to a particular variable. Okay. Then we moved on to how to access global variable using scope resolution operator, and then we move on to how to define a class define a function outside the class. So these are the first 6 programs for the first class that you have to execute. So I want all of you to prepare a lab report where you write the program and the algorithm for each of the program. Okay, you should not print it, you should rather write it. So in that way, what you'll be able to do is you'll be able to understand as well as remember the way how the various syntax has to be placed, and the way how the various objects can be used. So thank you very much. Have a good day.